Alright, so chapter 6, introduction, part 2. In part 1, we introduced the basic idea of Thomas Young in order to prove that light was indeed a wave. Now, what we're going to talk about now is what can we expect to see on the screen. So, just a reminder what we talked about in the last video. There are a light source on the left, it passed through a screen with a small slit, and it passed through a second board with two slits, and this creates 2-point source. The light here will interfere. Now we cannot see that interference right away. So what we do is we place a screen. Now at this point, light still interfere and we can see it. Now there will be different fringe that will happen. These are small bar and they will have different brightness. Now it's really hard to draw brightness on a whiteboard. So what I did instead is something that looked like a sine wave with crest and trough. Now the bigger crest indicate that it's a higher intensity or a brighter fringe in this case. All right. Now at the point where we have these big crests, it's the point where the wave will interfere constructively. And we've seen before that happen when the two waves are exactly in phase. Just like akin to a water wave, when they meet each other at certain point, they interfere and it creates a bigger wave. Well, in this case, this happened continuously, all right? We then have the trough, and this is the reverse idea basically. So the two waves are out of phase by 180 degrees, which means that the two waves cancel out each other at all time. All right, and this pattern continues with the crest and trough until basically we get out of the screen or they are not bright enough for us to be able to see them. Now, we will see in the next few videos, we will explain mathematically where we can expect to see these fringe. So we are going to be talking a lot about the minimum and the maximum. And I just want to make sure we are all clear on this notation. Whether we're talking about the maximum or the minimum, we are going to use the letter M and we're going to attach to it an integer. And depending on the integer we attach to it, it means we are talking about a different fringe. So I'm going to start with the maximum drawn in blue. So the first one we want to talk about is when M is equal to 0. That's the central maximum. This is the brightest fringe always. Then we have M is equal to 1 or minus 1, and these are the two fringe next to each other. Now we will see in the next video that the distance from the central one to the two next to it are exactly the same distance. So the same distance downward, the same distance upward. And same logic for all the other fringe, all right? So in this case, I drawn 3 fringe on each side, all right? When we talk about the minimum, well, there's no central minimum in this case. So M cannot be 0 for the minimum. It can be plus or minus 1, plus or minus 2, plus or minus 3, and so on, but it cannot be 0. So M is equal to 1 in this case. We're talking about the two first minimum right next to the central maximum. And the same logic, so this is M is equal to 1, this is M is equal to 2, this is M is equal to 3, and so on until, well, we are not able to see the trough again anymore. All right? In the next video, we're going to talk about the mathematics of why this interference happened at a certain point, and we will see that we are able to predict exactly where the crest and trough should appear. All right? So see you in the next video.